Hi class, today we're going to be learning about the properties of addition and multiplication. This will be covering the standard 6.EEI.3, apply mathematical properties such as commutative, associative, and distributive to generate equivalent expressions. So first we're going to start with the properties of addition. There's the commutative property, which states that changing the order of addends do not change the sum. All this means is that I'm taking this 3 plus 2 and flipping the order to 2 plus 3. Think about taking a commute to work. If you take a commute to work, you're having to go from one place to another. So just in the same idea, where all we're doing is just switching the order of our addends. To prove to you that this does generate an equivalent expression, meaning an expression that has the same sum, we can look at this as 3 plus 2 is 5, and if I add 4, I'll get 9. And that's the same thing as 2 plus 3, which is 5, and then I'll add 4, which is also 9. I apologize for that stray mark. Let's erase that really quick. Alright, moving on to the associative property. And the associative property states that changing the grouping of the addends does not change the sum. For instance, 3 plus 2 is 5, and if I add 4, then I'll get 9. In the same idea, I can move my parentheses around the 2 and the 4. If I do that, inside the parentheses I'll get 6, and if I add 3 to 6, I'll also get 9. So in both instances, I got 9. So all we're doing with the associative property is regrouping. We're associating our numbers in a different way. Now let's look at the additive identity. This states that the sum of any number and 0 is that number. For instance, 3 plus 0 is 3. So it's just saying that any number, if I add 0 to any number, then I'm going to get that number. Let's look at the additive inverse. An inverse is just the negative version or the opposite version of that number. So a number plus its inverse equals 0. So negative 2 plus 2. The inverse of negative 2 is 2. Or you could say they're opposites. Because if I add them together, I'm going to get 0. If 2 was in front, then I would have 2 plus negative 2. If it was 3, it would be 3 and negative 3. You kind of get the idea. So let's break this down a little bit. Here's an example problem of 4 plus 5 plus 1. If I solve this using the commutative property, instead of saying 4 plus 5 is 9, and I'm going to add 1 to get 10, I could say 4 plus 1 is 5, and then add 5 and get 10. In a similar mindset, I can use the associative property to say that 4 plus 5 is 9, add 1, get 10, and 4 plus, and then I group my 5 and my 1 together to get 6. So here I just switched the order to make it easier for me to think about, and here all I did was regroup to give me some number fact that I might know better. So how can this help us solve much longer equations? Well, here we start with our original. 2 plus 6 plus negative 2 plus negative 5 plus 3 plus 5. If I use the commutative property, I can switch this 6 and this negative 2, and I can also switch this 3 and this 5. When I do this, I put my 2 and my negative 2 together, and my negative 5 and my 5 together. Using the associative property, I can actually group those to where they're actually solved on their own. Using the additive inverse property, I know that any number plus its inverse is going to give me 0. So, using the additive identity property, that tells me that 0 plus any number is that number, then I'll know that 6 plus 3 is equal to 9. So we started with the commutative, where we just switched the order, then we grouped with the associative property. We knew that adding an inverse will give us 0, And the additive identity property told us that any number plus 0 is that number. Very similarly, there are also properties of multiplication. There's the commutative property, which states that changing the order of factors do not change the product. So 3 times 2 times 4 is the same thing as 2 times 3 times 4. All I did was switch the order. The associative property, which states that changing the grouping of the factors does not change the product. So just like the associative property of addition, all I'm doing is moving the way I'm grouping the numbers. The multiplicative identity states that any number times 1 is that number. So very similar to adding 0, here we'll multiply by 1 to get the same number. The multiplicative inverse states that a number times its reciprocal is 1. So instead of working with opposites, this time we are working with reciprocals. Reciprocal is just 1 over the number. So 15 times 1 over 15 will give us 1. And that makes sense because if we have 15 over 1, and we multiply that by 1 over 15, then that'll give us 15 over 15, which is 1. And the distributive property, which is kind of a mixture of multiplication and division. It states that the product of a factor and a sum is equal to the sum of its products. So for instance, 3 times 1 plus 2 is equal to 3 times 1 plus 3 times 2. So we can solve this by saying our original problem was 4 times 1/4 times 1 times 1. Using the commutative property, I can switch the order of these two middle factors, and I'll get 4 times 1 times 1/4 times 1. Using the associative property, I can regroup these numbers to where I get 4 times 1 and 1/4 times 1. The multiplicative identity property tells me that any number times 1 is that number. So I know that 4 times 1 is 4, and 1/4 times 1 is 1/4. Then, using the additive inverse property, any number times its reciprocal is 1. So 4 divided by 4, or 4 times 1/4, which is what it states here, is 1. So using my properties, I was able to simplify this expression into something equivalent. Very similarly, we can do it with 5 times 6 times 3 times 3. That's our original. And then we go to the commutative property. And the commutative property allows me to rearrange the order again. So I'm just switching these two middle factors. And I get 5 times 3 times 6 times 3. Using the associative property, I can group those together. And I'll get 15 times 18, which is 270. Or, if I don't use the commutative property, I can jump straight to the associative property and just regroup these numbers together. And I know 5 times 6 is 30, and 3 times 3 is 9. And 9 times 3 is 27. And then I want 10 times more than that, so I'll get 270. However, please note that because we don't have any addition here, we cannot use the distributive property. That's a common error I see students make. Similarly, there is no reciprocal here, so we can't use the additive inverse. Here's an instance where we would use the distributive property. If we have 5 times 3 plus 6 times 3, I can factor out that 3, and then I'll have 3 times 5 plus 6, and I can solve that by saying 3 times 11 is equal to 33, which does make it a lot faster than trying to solve this equation up here. Alright, now I want you to solve these two problems on your own and identify any properties that you use. You are to turn in the answers with all the work shown for homework tomorrow. Feel free to pause the video now and work on these and make sure you bring them in. Thank you. See you in class tomorrow.